So hi, I'm Feng Chen, and you can also call me Casey. I'm Shuram's PhD student here, and today I'm going to introduce Stacker, which is something like Stacker if you have ever used the HtDP language. It's a runnable notional machine for that language, and I'm also going to talk about how we use the Stacker in Shuram's programming language class. So this is a program written in the HtDP language. The most interesting thing, so it only connects to function definition and one expression. The interesting thing is the second function calls the first function. So, and also they both define a variable x. So to reason about this program, you need to think about how bindings are managed in behind the screen. And we can turn this HtDP language to a language called small. That is what we are using at Brown to teach programming language. So small stands for standard model of programming language. Here standard, you can read the standard as consensus because we are seeing many programming language are kind of evolving to the same direction. At least a similar direction. Well, to change from one language to another, we have to first change the hash line. And we also replace define with define because we want to separate function definition and variable definition. But they all work like define in Racket. And now I want us to focus on what happened when the line 4 is executed. Here, when function, so when we compute the subtraction, f at the function g is called, and we are waiting for the function output to do the subtraction. And in G, we have a multiplication, which will be waiting for the result of F. So when we get to this X line, we can see two computations that are waiting for X. And if you run this in the stacker, you will see exactly the thing. And let me slow down and introduce what is going on here. So here, this part, the top left part of the window screenshot, you can see a stack which summarize all the pending computation. And each stack frame will give you an evaluation context. It's a local evaluation context, not the whole continuation and not the whole stack. Which also include environment pointer. Well, actually this pointer is not important in this frame, but we will see why we need that in the next frame. Here we can see a multiplication is waiting for something. Using this box as notation from standard PL semantic. And here we can, because we have got a free variable x that comes from line 7, we need to know what's the meaning of that x. So that's why we have this environment pointer, which says x should be bound to 2 in that environment. Eventually, we can see that now we are computing the x in the function body, and in this environment, x is bound to 3. The stacker supports things more than that. So we also have mutable variable, mutable vector, closure, and local binding forms such as that, style, and rec. This is just a program that illustrates all the feature, also the feature that we supported. And you can also run this program in the stacker, and you will see two new kind of boxes. The top one on the very right column is a visualization of the vector. And below that, the light green box is a visualization of the closure. So now I want to get to how we use the stacker in the programming language curriculum. Basically, we start with some example program and their result. And they work like kind of like the training set in, say, regression model, etc. We use those program and their result to force students to construct a mental model of how those programming languages work. And after that, we will show them the stacker, which give a perspective of the model or a more accurate description about the model. And we also want to make sure students understand what is shown by the stacker. And that's why we also create some assignment that has students' understanding of all those pictures. And the first kind of assignment is about mapping those screenshots to the result of the program. For example, we will ask students to understand pictures like this. So they will see a very big stack and some environment. You can see some variable are defined multiple times. So they have to know which environment is inside which, etc.
Question.
Yes.
So just to be clear, you're saying that you show them this picture and you say, what is the result of this program? And they write down 8 or whatever it is.
Yes.
Okay, thank you.
And we also have another kind of questions that, in which case we also show them pictures, but this time we want them to write program that will produce this picture. So, well, this one is not very difficult. It's also the first picture that we show them. It's just like two functions and calling each other. What's really interesting is something like this. So we have two vectors that point to each other. And in this case, they need to figure out how do I, first of all, they need to realize that vector can point to other vector. And they also, yes?
What does this mean in context point all?
Oh, so this is the first stack frame, which means we are at the top level of the program. And if in the context will accumulate all the computed results. Here we have two void because we actually have two vector set bank in order to construct this program. Does that make sense? Yes.
Maybe this is a follow-up to Robbie's, but like, why aren't those voids gotten rid of? Because they're like, with the safe for space evaluator, they wouldn't actually be included on the stack.
Yeah. Okay, we are still so I think that's a design choice. If you show all the value, you can immediately tell how many expressions are there at the top level, which might help students understand this thing. And on the other hand, yes, removing those values might be a more accurate description of what is actually going on. And we are still thinking about what would be the best design and thinking about their trade-off. That's what all the thought we have so far. Yes.
Can I read into this that you are not doing tail call optimization? Or you're lying and you're doing it, but you're still showing the stack frame?
We are doing tail call optimization. So if you have a for instance, if you actually have 3 functions rather than 2, but one of the functions is tail call, you will still see this picture.
So the thing is that the frame on the very top, the context is empty. So wouldn't that be a tail call that gets removed?
Aha, because we lie a little bit in the very first frame. So there is actually a top level surrounding everything in the very top frame.
So that's, hash percent top level begin printf.
Yeah, exactly.
Okay, one other question. Is this UI interactive with arrows like the PLAI GC display, where when I hover over 1324, there's like an arrow over to that environment? Or do I have to like connect it in my head?
Currently, you have to connect it in your head.
Is that a feature that you have to connect it? Like, do you want them to connect it? Or is it just you haven't implemented the arrow yet? Do you understand what I mean?
Yes, I think that's a very interesting question. So we actually did a user study this semester, and we compared the stacker with Python tutor. And Python tutor actually use arrows to connect all those blocks rather than showing the address and the people connect in their head. And we are collecting student feedback, we are actually processing the data, but currently my impression is that if you only use arrows, when there are too many things, the arrow can become messy. And when you only have edges, well, that can be very difficult to reason about too, especially when you want to compare 2 pictures and see if they are of the same structure. So we are using random method. So I think the design choice that you point out is actually a very good place in the middle. Yes, sure.
Yeah, I just want to add one comment to that question. I think it's a great question. One of our arguments for using the addresses is it actually might lend a little bit of authenticity because part of what we're trying to do is to explain a low-level machine model, and having addresses, giving a sense of like, this is conceivably how your computer sort of actually runs without actually being real addresses is something that we've noticed seems to have a little bit of value, but we're still trying to, as Casey said, we're still doing user studies and exploring those dimensions.
Yeah,
but
I believe it is
the addresses because there is some authenticity there about the machine model.
Yeah, I believe it is a feature to have the addresses. My only suggestion is to show the arrow when you hover on the addresses. That's what the PLAI GC display does.
Gotcha. Yeah. Yeah, thank you. We were here, and eventually, our very last question to students about constructing program that produce this feature, we actually showed them two pictures, and saying, well, C1, the top picture is the first one, and if you click next a couple of times, you will see the next picture. And the program behind these two pictures is a lambda that resides in a let. And that
over lambda.
Yeah, that over lambda.
Did you black that out for the slide, or did you hand them a blacked out thing?
We hand them with lambda body blackout because we wanted to write a program, and if you show the function body, we will be giving out too many about the solution.
Okay.
Good question.
Are you going to tell us if the kids can answer it?
They can, and actually they have, some of them even have very creative answer.
Correct.
As for how creative the answer is, I think this program is fine. I think we see creative answer in other questions. Yes?
What does if previous and next do? Just like up and down the stack, or just like?
Actually, this might be a good time where I do a demo about the stacker, and I think that will answer the question. Let me see what would be a good. Let's just use the first example. So if I click run, well, initially we will be doing the function call. If I click next, we will go to the next point during the chain of execution where the stacker stopped. And I think we stop before and after function call, and whenever a mutation happens. I think we also stop right before the function return. Yeah.
So in particular, it skips over steps that Clemence's stepper would have shown, like a conditional, for example. The body is only going to explain function call, function returns, and mutation.
I think this is actually a design choice. I mean, what are the places where you want to stop? And because in our curriculum we want to focus on lexical scope and mutation, so that's how we end up choosing this place. Yes.
How hard would that be to make configurable if I wanted to have a few more steps in between?
It's not available right now, but I think that's something I can add in like 2 days.
I'm gonna, Jason, I'm gonna push back a little bit against that. I am unconvinced that having too many steps is actually useful. I don't think having too many steps is useful, but I think it's the right number. we think we have the right number. But I think thinking of this as something you can configure maybe makes more sense, right? So maybe conditionals are what you want to emphasize or something like that. I'm unconvinced that many of the steps that the stepper shows are actually that useful, that's something students are actually that confused about. And the combination of that plus overwhelming number of 3D steps, I think is actually the problem.
Yes.
I don't like that there's no connection to the line numbers in the stacker display. Are you ashamed of this and you're going to fix it? Or have you deluded yourself into thinking that it is a feature? James.
Actually, I think Shiran brought our very similar comment while I developed this too. But we end up finding it's kind of nice to show everything just in the picture. Especially when we want to have assignment where we give them a picture and let them write a program. Yeah. So if we give them line number, for instance,
that
would be
I think it works. I think it works to hide the line numbers for the tests. But I feel like right now I want to know like which minus block 3 is that if there were 2 in the program. You know what I mean?
Yes.
Yeah, and I think line number would be much better than showing those 2 voids that we had before.
Aha, I see your point. Yeah, thank you. Yes.
Is this something that's like available to use online?
Yeah, it's on GitHub.
Get this in? Okay.
Yeah.
Because this seems like has a lot of potential for teaching students.
Yeah. I guess Robin raised hand first.
It's maybe a little bit in the weeds question. So, all of the holes so far that have been inside expressions like subtraction and multiplication have always been on the left, and every example you've shown so far. They've always been in the first position. And so I'm wondering what happens when.
Repeat the question.
Oh, okay.
I noticed that all the holes are always in the first position in any subexpression in all the examples that have been shown so far. And I was wondering if that's, I was wondering what you would show when the hole is not in the first position. Would you show the evaluated things to the left, or yeah, so instead of minus G23, do minus the sum of 1 plus 2 G23.
We'll replace that with a value.
Okay.
So, for instance,
yeah,
you will see 5.
Is that better than showing me
The expression?
Yeah.
I didn't think about this problem. So, do you have anything on the top of your head? What
No,
would be
I was just curious.
Okay.
I think it makes it a little bit harder to show where that
Model is show values on the left of the whole and show unevaluated expressions on the right, because in particular, you might have variables and you want to make sure that they understand that those variables might be mutated by the time you get to evaluate them. But get rid of the details on the left.
That makes sense.
I remember there's a question.
I had an isomorphic question.
Okay, thank you.
Could you show replacing the plus 2, 3 with like G3?
G3, yeah, sure. So this one becomes G3. Is that what you expected?
Yeah. Well,
Why did you stop there? Just out of curiosity.
Stop before function call.
Is that the rule? Stop before a function call?
Yeah, because so we also make this box yellowish color, and we want to stop here so that when you click next, you can see a very isomorphic box move up. Yeah.
So is this language first order, or do you have map? Things like that.
Could you say that again, sorry?
Is this a first order functional language? Or?
No, we have closure.
Okay, what happens if you do like map of G over this one too? I'm curious what the G displays like when you put that in the.
Easy, just do a map.
I'm not sure if I have a map here. That's why I hesitate. Let me try. In some version we have it. Oh, we actually have a map. Good.
So map G.
I like those cons boxes.
So, I'm going to interrupt this with a very important question.
Yes.
How are you drawing this? Is this a snip? Because it looks a lot like Racket's like picked or snip library.
It's drawn by pick. It's drawn with pick.
It's picked. Okay.
Yeah.
Thank you.
This is so beautiful.
Thank you.
Can you step it a couple times?
Yeah.
And select.
Yeah, I guess I expose the body of map. So maybe let me step one more time.
So it's not Racket's map, that's your map.
Yeah. Yes?
As someone exposed to 3 rounds earlier experiments on these stacked assignments, thank you for rescuing us from the terrible tools that we have to use for that.
What tools did you have?
The visual programming language, what is it called?
Snapbox.
Snap, yeah.
Oh.
It was terrible. We had to
I loved it. We're gonna bring it back. The moment Leaf gets like the DOM embedding, we'll be back to that, and then we'll be sorry.
I remember there's another question. Okay. Okay, any other question? Oh, good. I don't want to steal time from Siddhartha, who is also a Shuron's PhD student and is giving a talk after me. Oh, I wonder where to go. Okay, so if you are interested and willing to try Stack, I will be very happy. Thank you.
Thanks, Casey.